We're interested in developing a better understanding of input structures in interactive computer graphics. What we would like is to have a good methodology for answering three basic questions. Confronted with a design decision, what are the alternatives? What are the characteristics of each of those alternatives? And how do we find the best match between our needs and those alternatives? In this tape, what we're going to do is take a look at a particular class of tasks, selection positioning tasks, and go through some of the different alternative techniques for their performance. In so doing, we want it to be representative of what we believe should be done in many other areas or classes of tasks, and basically develop a methodology which will help bring the understanding which we seek. Selection positioning tasks are interesting in that they are compound tasks, and they're tasks which we find in many applications. For example, selecting different gates in a logic design system, where we select, for example, an AND or an OR gate and place it on the workspace. Or another application might be, for example, in music, where we select a note of a particular duration and position it at a particular pitch. The study we're about to show you is simple enough to make things clearly understandable, and yet has sufficient complexities to bring many interesting features of selection positioning tasks to the fore. The case study involves selecting from among one of three geometric figures, a square, a circle, and a triangle, and positioning them in this two-dimensional workspace. We'll look at several different techniques for doing the selection and positioning, and we'll discuss the properties of each as we go along. In doing so, we will constrain ourselves to using the graphics display, the typewriter type terminal, and the graphics tablet. The first technique which we're going to use is called dragging. And what we will do is simply move the pointing device over top of the item which we wish to select, depress the yellow button on the cursor, and drag the shape to the desired location. When it's in the desired location, we release our finger and the shape is anchored. I'll repeat that with a circle. I'll go to the circle, select it, hold the button down, drag it across, release it, and it is anchored. If I don't go back to the menu item over here and depress the button, I get a question mark, which immediately brings up one important point. That is, that diagnostics come in the form of iconic or pictographs, in this case a question mark, at the focus of my attention, that is, at the tracking symbol. Technique, we can select several items and lay out complex patterns. One important point about the technique as seen thus far is that there's a tight coupling between the gesture which selects the item, that is the pushing the button down, and the anchoring of the item, that is on the release. The point is that the down and up motion are tightly coupled, and therefore the two steps of the operation, selection and positioning, are bound together in a single gesture, much in a way analogous to a compound word. One of the problems with this technique, however, is the necessity to go back to the menu every time we want to select an item. For example, if we want to have the same item several times in this display, the hand motion is rather wasteful. We can, in fact, make a different version of this technique, which exploits the redundancy of several types of usages. In this case, we can point to the triangle, drag it across, anchor it as before, but we still have a triangle on our cursor. So every place I depress the button, I will get a triangle. In essence, going across to the menu is like dipping your brush in a painter's palette, and now I've got the color or the shape on my brush. I can dab over top of the locations that I want that color, or in this case that shape, to appear. In so doing, much hand motion is saved. The second main technique reduces hand motion considerably from the previous techniques. In this case, instead of going over to the menu comes to us. We point to where we want the shape to appear, depress the button, and what happens is the tracking symbol, or the cross, which was previously moving, becomes anchored at the location where the button was depressed, but in its place, I have a moving menu. So what we had is the inverse of before. a stationary pointer, and a moving menu. To select a triangle, I simply place the triangle over top of the marker and release the button, and it's anchored. I'll demonstrate that again. Point, depress the button. While holding the button down, and only while holding the button down, I have a moving menu. I place the item I want over the tracking symbol, release the button, and it is anchored. Again, there is a redundant version of this technique, just as there was of the previous one. In this case, we'll point, depress the button, and when I release it with a triangle, you notice the next time I depress, the triangle comes up over top of the pointer, so a simple down-up motion will get the item. The two techniques seen thus far already present a couple interesting questions. One of them has to do with the syntax of performing the selection positioning tasks. In the first technique, the dragging, we did the selection first, followed by the positioning. In the second technique, the moving menu technique, we did the positioning first and then the selection. This syntactic reversal could in fact cause problems. One may be more natural than the other. The point is, we don't really have the answer to that question, but this type of environment which we're constructing and demonstrating right now is a useful environment to actually perform the experiments to answer those questions. There's another difference or question that comes up in the two techniques, and it has to do with the number of items that can be selected. In the former technique, the dragging, where the menu is coming down the side, we generally have room for more menu items before the screen gets cluttered. As the number of menu items gets larger on the moving menu technique, the technique's effectiveness breaks down. Also, the dragging technique utilizes real estate on the display, which is not required by the moving menu technique. Therefore, in areas where display space is at a premium, perhaps the second technique is better. And finally, there's a question about the documentation. The dragging technique is fairly obvious in terms of what the user should do. But in terms of the moving menu technique, there is nothing in front of the user to prompt him as to what the course of action he should perform. The previous two techniques introduced some problems of syntax. Which came first, the selection or the positioning? The next technique which we're going to see involves the use of a character recognizer, which has the interesting property that it integrates the selection and the positioning tasks into a single gesture. We have three different symbols that are recognized by the system. For example, a check mark, as this, defines a square, an upward stroke a triangle, and a downward stroke a circle. This technique allows the user to use a simple type of shorthand and very quickly input items. The technique does have some drawbacks or important properties for the user to understand. Among them is that of the cognitive burden of remembering the different symbols. The more symbols there are, or the more items to select from, the more symbols the user must remember. This brings up the whole question of what should the symbols look like? Should they be representative? For example, in this case, why didn't I use a symbol that looked like a square, a circle, or a triangle instead of these various strokes? The answer lies in the fact that it's easier to recognize single stroke symbols, and secondly, it's easier to draw them. If we have to draw an AND gate or a picture of a transistor or even a pictograph of such a device, the gains in using the technique are lost in the time it takes up to draw those complex symbols, even if the user can remember them. The next technique involves typing. And in the context of a graphics lab, this often is the last technique that we'll look for. What we do in this case is type a symbol to say what the shape we want, in this case an S, followed by the XY coordinates. For example, 512, 512. This will position a square in the center of the display. Now, there's a couple important points about typing. First of all, we could say it took much longer to enter that square than if I had have used the character recognizer, for example. But we have to be cautious in making that type of conclusion. If we had a subject here and we were performing an experiment to say, duplicate a picture which I've defined on a piece of paper, if the picture on the piece of paper was drawn as images, it's clear that the previous techniques would in fact be faster than the typing. But if the picture was defined as a list of coordinates, as is often the case in scientific data, then clearly typing and an experienced typist would be a much more efficient technique. Typing also has the attribute that in applications where a high degree of accuracy is required, that it often is a superior technique. Finally, the typing does not require a graphics tablet and the cursor and so on, and therefore eliminates equipment which may be expensive or impractical in a particular environment where the application must be installed. The final point to make from this is that we have seen some cases where typing is superior to the previous techniques and vice versa. I would maintain that for every technique which we have seen, plus the next technique which we are going to see, that there is in fact a formulation of the task which would make that particular technique optimal, and there's probably also a formulation of a task which would make any technique the worst of the lot. The final technique which we're going to look at is similar to the character recognizer in that it integrates the selection and the positioning tasks into a single gesture. This technique uses function keys. We simply point to the region where we want an item to be selected and push down the button appropriate to that shape. In this case, I'm using the cursor buttons for the triangle, circle, and square. And so when I point to the item, which shape I get or select depends on which button I push. So for example, I'll now get a circle by pushing the blue button. The technique is as fast, if not faster, than the character recognizer and is much easier to implement. Some important questions come up here again, however. One of them has to do with where should the function keys reside? For example, is it faster to have them on the right hand on the pointing device, as here, or on a device such as over here, where I have similarly 4 different buttons? One could answer that in many cases, why use the left hand if the right hand is capable of performing the task? That leaves the left hand free for other tasks where necessary. The second point comes down to ask, if we have a cursor with several buttons, how many buttons can we get on it? They make, for cartography purposes, for example, cursors with up to 32 buttons. Clearly, the effectiveness of the function key breaks down as the difficulty in finding the appropriate button increases. In summary, what we have seen is a number of different techniques for performing the same type of task. What we've learned from this is that each technique has a peculiar set of characteristics, and furthermore, that we don't really understand the relationship of those characteristics to various types of applications. What we hope that this study has shown is the need to perform increased research in this particular area, and also demonstrated what we believe is a viable methodology for performing such a probe.